Okay, so let's go over this. Oh, no, like this. Like this. Yep. Okay, so first question, determine if a table shows a proportional relationship. If it is proportional, what is the equation? Okay, so one way you can do this is find, well, in several ways. Here is your point x, x and y. If you do k, y equals x, for this point right here, and I'm talking 1 over 5, you would get 5 over 1, which is 5. So your constant of proportionality is 5, and your unit rate would be 5 over 1, or whatever that is. We don't have information, but that would be. Let's take the second one. The second one would be 10 over 2, and you have to be really careful in who you put on top and who you put at the bottom, right? Because it's y over x, and make sure that you put the y, which is 10 over x. And also, you get that k equals 5. The third one, if you did the same, is 5 again, and the last one will be 5. So definitely, it is a proportional relationship, and you can clearly tell because it's times 5, times 5, times 5, times 5, right? So it's clearly proportional. So what is the equation? Well, if this is the, what do you call, the constant proportionality, y equals kx, right? So it would be simply y equals 5x. And you can always double check, so I'm going to use the last one, 420. So I'm going to substitute, this is my y value, this is my x value, so I would get 20 equals 5 times 4, and you can tell that they're equal to each other, and it's therefore this point 420 exists in this line 5 equals 5x, y equals 5x, which would look something, a line like that, and 424 would belong on top of the line. Okay, so a lot of things, a lot of different ways you can do it. Okay. Sam uses 8, blah, 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 blah. How many calories does he use in 1 hour? I forgot to bring my calculator. Okay, so 845, and I would write it like this, calories over 2 1/7 of an hour. So how much does he use in an hour? Well, we want the unit rate. And I would change this 2 1/7 to 7 times 2 is 14, 15 over 2, right? So I am going to rewrite this as 15 over 2 hours, and then I'm going to multiply by the reciprocal, which is 2 over 15, and therefore that's how I get my unit rate of 1. And on top, I'm going to divide 845 divided by 15 over 2 again, and I would get, etc., calories, and you can leave it as a fraction. I don't have a calculator, that I'm not going to look for one right now. 845 times 15 equals blah, 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 divided by 2 equals 6,000. Nope. Something's wrong. Oh, that's because I used 15 over 2. It's supposed to be 2 over 15. Sorry. 2 over 15. Let's try this again. 845 times 2 equals blah, 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 divided by 15 equals to 112.66666, which tells me it's going to be, as a fraction, so let me rewrite this. It's going to be 112 2/3 over 1 hour, 112 calories per hour, which doesn't seem right. Oh, wait, well, no, 113. No, it doesn't seem right as well. No, it's right. No, wait. 113 times. Hang on a second. Times. No, something's off. 845 times 2 equals that. Divide that by 15. That's what I get. 112.66 per hour. Why don't I feel like this is correct? Should be more. Sometimes it's 14 plus 1. Oh, okay. So ignore everything I just did, please, because that 2 doesn't exist. It should be a 7. So it's too early for this. So 7 times 2 is 14 plus 1 is 15 over 7. And I'm going to change that to a fraction. Now, I divide that by 15 over 7. And I get 1 hour at the bottom. And I divide the top by 15 over 7. So 845 times, or Right, so, and again, I'd rather write times 7 over 15. It's the same thing, divided by 15 over 7 times 15. I'm just taking a step further. And maybe now I can do that. Times 7 equals, divided by 15 equals, that makes more sense, 394. And you can write 4/5 if you have a calculator that has a fraction, or it's 394.8 calories in 1 hour. Okay, that makes much more sense. Good thing I caught it. 3, find the equation of line, create a scenario that will explain 0 and 30. Okay, so at 0 time, he already has, not 0.30, this should be 0.25 by the way. Okay. Explain how is it that 0 weeks he already has 25. Well, if this looks like a savings account, maybe his mom gave him 25 bucks to start with, and then he started depositing a certain amount every week. So that's definitely what is happening here. So if this is the equation of the line, one thing I know for sure is this b. It's already 25, so I have to figure out what the slope is, right? And to find the slope, you pick 2 points, any 2 points. So let me just erase that. Let me pick point 1 and 30. Let me pick 2 and let me pick 3 and 40, right? Because I need my m. So m equals y2 minus y1 over x2 minus x1. So let's make this guys the x1s, these the x2s. So I get 40 minus 30. And I'm going to get 3 minus 1. And I'm going to get 10 over 2, which is 5. So my slope, my m, equals 5. I already know what my y-intercept, because it's clear on the equation. My b is 25. So I have everything I need to create my equation. So y equals m, which is 5, times x, plus 25. That makes sense. If you want to substitute, just to make sure, let's substitute 0 and 25, right? The point 0, this should be 25, by the way. Let's see if that makes that equation true. So I get 25 equals 5 times 0 plus 25. This will be 0, and 25 equals 25. So it's true. You can check a couple other points just to make sure that this is the equation of your line. Okay. 4, which one represents a proportional relationship? Okay, so quickly, so if you do y over x, even if you just look up and down, well, this is 2 times 8, this is times 9, and this is definitely times something. I have no idea what it is, but you already can tell that your constant proportionality is going to be different, right? If you do y divided by x, this is 8, this is 9, this is going to be something else. Over here, negative 1.5 divided by 1 is negative 1.5. Negative 3 divided by 2 is negative 1.5. And negative 4.5 divided by 3 is negative 1.5. You see that the k is the same. Remember, k equals y over x. Right? So this is the one that's proportional. And it goes through 0, 0. Well, this one doesn't even. At 0, it's your y-intercept is negative 4. So this one looks like this, and this one looks like this. For any equilateral polygon, is the length of the side proportional to the perimeter? Be careful. So let's take a triangle, equilateral. All right, so is the length of the side proportional to the perimeter? So if this is 1, this is 1, this is 1, the perimeter. So if the side, so let's say the side, and let's call the perimeter. So let's say side, let me create a table. If the side is 1, the perimeter is 3. Yeah? Because I add all the. What if I change the side to 2? If the side was 2, the perimeter would be 6. What if the side length was 3? The perimeter would be 9, and so forth, and so forth, and so forth, right? Do you think they're proportional? Looks like they are, right? Because it's times 3, times 3, times 3. So definitely, or divided by 3, divided by 3, divided by 3. So take a square. Imagine that the size of the square was 1. The perimeter would be 4. If the size of the squares would be 2, the perimeter would be 8. If the size of these squares were 3, the perimeter would be 12. So is there a proportional relationship? There's definitely a proportional relationship. So you can pick any shape. I don't know. Let's pick a 1, 2, 3, 4, 5, 6. Now imagine that this is, imagine that this is equilateral, all the size measures. So we've got 1, 1, 1, 1, 1, 1. If you create a table, and the perimeter would be 1, 2, 3, well, it would be 6 because that's the size. If I change this, the length of the sides to 2, it would be the length of the side of one side would be 2, which makes the perimeter 12. Right? You can clearly tell that it stays proportional. Okay, if the length of the sides were 3, okay, so if the length of the side was 3, the perimeter, which is the sum of all the sides, would be 18. Again, you see that relationship stays times 6. So it is proportional. Write the equation of the line. Okay, this one's not easy. So in order to equation the line, and this says, let me pick a rate. Well, it's proportional, so I can definitely use y equal x. It's going to be in this format. There's not going to be any y-intercept. This b over here is going to be 0. So there's no point in writing it, so you can just focus here. So for that, I will pick a point that I can see clearly, and the point I'm going to pick is the airplane size and the production cost. So the x value, let me pick 200, and the y value is going to be 100. So that's this point right here. This point right here is 200 and 100. Yeah. So if I were to do y equals kx, or if I did k equals y over x, k would be 100, and y would be 200, and k would be 0.5. Right? So that's it. If you wanted to pick another point, 400 and 200, the same thing. It would be 200 over 400, right? You just got to be careful as who to put in. Remember, this is your y value, this is your x value. So I found my k, plug it in, y equals 0.5x. You want to double check. Let me pick a different point. Let me pick this point right here, point 600, right? This one, 600, which matches with 300 on the y-axis, and plug it in here. See if it matches. So y is 300, right? This is my y, this is my x. And then I get 0.5 times 600. 300, and half of 600 is 300. Check. So I know my equation is correct. Okay, so that would be the equation of your line. Taylor works 45 hours to earn $832.5. What is the concept of proportionality? Write an equation. Well, if that's assuming it's proportional, right? It's proportionally makes the same every hour. We can write this equation. We can write it like this: 832, 45 hours, right? We can also write it like this: 45 and 832.5, right? This would be your x, and this would be your y. So imagine if you had a graph, your hours would be here, your dollars would be here. So 45 hours, which is, let me just put over here, 45 hours, and this is 832.5. So there's a point in the graph, right? So now I can use that to find the constant proportionality, which is y over x. So if I divide 832.5 divided by 45, I would get, so I'll write 832.5 divided by 45. I get that my constant proportionality is 18.5. This is K, which means she earns 18.5 in 1 hour. So that's the unit rate, right? That's the unit rate. And we can write our equation. Y, well, y equals kx, or y equals 18.5x. Okay, that's it. It takes him half an hour to write 1 and 3. How many pages does he write in an hour? Okay, so 1 3/5 pages in 7/8 of an hour. So in 1 hour, how much many pages do I write? This is actually based on facts. It's not easy writing in review sheets, by the way. Multiply that by 8 over 7, multiply that by 8 over 7. This is my 1 hour, and on top I multiplied that. So let me just change that. 5 times 1 is 5. That becomes 8 over 5. And I'll multiply that by 8 over 7. I'm changing that to a improper. Can I cancel anything out? No, so I get 64 over 35. And if you change that to a, what do you call, mixed number, you get 1 and 64, 1 and 29 over 35. Okay, so pages in 1 hour. 9, what is the constant proportionality? Write an equation. Okay, again, so pick a point. So it's proportional, first of all. So, right, so it's feet per second, so you're measuring feet per second. So I'm going to pick 2. No, that doesn't work. Looks like 10 works. Look, 10 seconds with 4 feet matches nicely right here. So that's the point. What? That's the point. 10 and 4. This is my x. This is my y. So y equals, k equals y over x. So I'm going to get 4 over 10. And 4 over 10 is 0.4. Right? So my k is 0.4. So the equation of the line is simply y equals 0.4. And you can double check. Pick another point that there's a point right here, 0.52. Right, in 5 seconds he moved 2 feet. So let's see if that's true. So y equals 2, 0.4 times 5, and if you actually multiply that out, you get 2. So 2 equals 2. Therefore, equation right, and that this point exists on this equation, so everything is good. 10. What's the better buy? What's the difference in what is the difference in cost? In cost per fluid ounce between the two sizes. So let's find the unit rights. Okay, so one is 96 over 12, 0.96, not 96, so 0.96. And the other one is 1.12 over 16 ounces. Okay, so find the unit rate. So 1 ounce here, 1 ounce here. All you gotta do is divide. So 0.96 divided by 12 equals, so this one costs you 0.08 cents per ounce. And the bottom one is 1.12 divided by 16 ounces. Oops. 1.12 divided by 1.12 divided by 16 ounces gives you 0.07. So the difference per fluid ounce between the two sizes is 1 penny. Okay, so this is more expensive than the other by 1 penny. So that would be your final answer. This is a proportion. There is a proportional. I don't like this question. Between a person's mass on Earth compared to the mass on the moon. The table below shows the mass, the two persons' mass compared to the mass on the moon. If Jerry's weighs 13.6 on the moon, what is his mass on Earth? So Tom weighs 78.5 pounds on Earth. On the moon, he would weigh 12.56. Mark weighs 98 pounds on Earth, and then on the moon, he weighs 15.68. Okay. So there is a proportional relationship, right? You're going to find your K here. Now, how much does Jerry weigh? So if Jerry weighs 13.6, how much does he weigh on Earth? Okay, well, this is just finding the relationship here. So we're going this way, right? So this, how does 12.56 become 78? We're going to find that multiplier, right? And to find multiplier, I would divide 78.5. 78.5-ish, 78.5 divided by 12.56 equals 6.25. So the relationship here says 6.25, right? So if I go backwards, if Tom was on Earth and he wanted to find out how much he weighs on the moon, we divide that by 6.25, and you would get 12.56. So there's your relationship right here. So therefore, Jerry, who is on the moon and he's going back to Earth, and we want to find his weight back on Earth, it would be 13.6 times 6.25. Times, oh my god, I need a better calculator. 13.6 times 6.25, that would give us, and he would weigh 85 pounds. So obviously, Jerry is a kid still. Okay. 12. Does the graph represent a proportional relationship? To justify your answer, what is the cost for 225 square feet of carpet? Okay, well, it is a proportional relationship. It's going through 0, 0, right? So let's find our equation. So 225 would be around, so if you extended the line, 225, I don't know, it would be somewhere over there. So you wanted that, extend that line, and see how much it would cost to meet with your y-axis, right? But we're not going to do that. We're going to use an equation. So let me pick a point that's nice. So let's say point 20, 30, right here. Point 20, 30. This is my x, this is my y, and I'm going to use that to find my k first of all. So k equals 30 over 20, and k equals 1.5. So now I have my equation on my line, which is y equals 1.5x. So now I need to find this point right here, right? 225. So this point is 225, which is the square feet per carpet, and I want to see what y value, which is the dollar, would be, what do you call, would match up with 25. So I know my x, but I don't know my y. Okay, so I can just either multiply, well, basically you're multiplying 225, right, times 1.5, but I'm going to show you. So you get y, which we don't know. It's 1.5 times 225, and 1.5 times 225 equals 337.5. So if you continue the y-axis here, this would match up with $337.50. Okay, that'll be your answer. The y value would have been $337. 13. Junior high school order 15 pieces, or 15 pies, pizza pies for $221.25. Write an equation to represent the relationship. Well, so your input would be the pies, and your output would be the money, right? So if I did this, I would get 221.25 over 15. 221.25 divided by 15 equals, really? 221.25 divided by 15 equals $14.75. So that's my k, therefore I can put my equation, and that makes sense. Every pizza is 14.75, so one pizza would be 14.75, blah, blah, blah. And if you wanted to just check, 14.75 times x, which in this case is 15, the total number of pizzas, do you get to 25? Yes, 221.25, yes you do. And if you want to graph, it would look something like that. Okay. 14. Tim is 5 years old. Okay. You can type 2/5 of a page in 12 minutes. How much can you type in 1 hour? Uh-oh, what happened? What happened? Here we go. 2/5 of a page in 12 minutes. And we want to know how many you can, well, really. 1 hour would be 60 minutes. So times 5 is a relationship. So times 5 here would be the relationship. And the answer would be 2 pages. Because this 5 and this 5 can cross out. and you get 2 times 1, which is 2. So in 1 hour, you can type 60 minutes, which is 1 hour, you can type 2 pages. Organic Fuji apples sell for $2.85 per pound at the local deli. Write in equation C the total cost of P pounds of apples. So this is what they're asking. This is now going to be called C, and this will be the P. Okay, so not every time you use y equals kx, you can actually use other letters depending on what do you call the scenario to represent total input and output. Okay, so the output is cost, right, the total, and the input is the pound. So that makes sense. So here you would have C equals really 2.85 times P. Not seeing the value of this question, but that would be it. Huh. Okay. 16. Which 2 points which 2 points would y equals yx pass through? So if you were to graph, so think about this for a second. If I told you here's your equation, y equals y over x, you know it's proportional, goes through 0, 0, and it will go like this, right? So therefore, will it pass through A and D, B, C? Well, I don't think E, doesn't look like it's not going to go through E, because if it goes through E, it would go through B or A, or there's no way. So anything that has E, it's already garbage. So it's either going to be A and D or B and C. So one of those two you have to pick. So let me erase some of this stuff over here. So definitely not C. Let me just put some number 2, 3, 4, 1, 2, 3, 4. I don't know if actually it's 1, 2, 3, 4, but I'm gonna pick. So let me pick point A, which is 2 and 1. All right, and let's substitute over here. If I substitute that, I get 1 equals half of 2, and 1 equals 1. So it passes through A. Let me see if it passes through D. Point D is 4 and 2. And you can tell that y will always be half of x, right? So that works. This is going to be works. Y equals half of x. Y in this case is 2, and half of 4 is 2 as well. So it definitely passes through A. It's going to be a line that goes like this. That's not going to pass through C. You can always double check. Okay, because 3, 4, 5. So if you look at the other part, let's take a look at point C. And point C is 5. Point C is 5 and 2, where x is 2.5 times greater than y. Well, that's not the relationship you want. Okay, you want a relationship where y is half of x, and here y is half of x, and here y 2 is half of 4. So it's definitely A and D, which makes it this one. Okay, yeah, letter A. 17. What is this? Identify 2 points in the line. Explain why they mean the context of this problem. Okay, so pick two points, and I would pick 2 easy points. And the first point that I see that's sort of easy is this one. It's exactly on the intersection there. So point 3, 4. Remember that this is the days, and 4 represents inches. So rising flood water. Okay, so this says that in 3 days, the water level went up 4 inches. Let me pick another point, and the other point I would pick would be 6 and 8. 6 and 8 also, in 6 days, the water levels went up 8 inches. Yeah. So if you also want to talk about proportionality, so if you do k equals yx, k equals 4 over 3, and then here k equals 8 over 6, and k equals 4 over 3 again. Right, simplified, and you can tell that both points, their unit rate is the same, constant proportionality is the same, so therefore makes the whole thing proportional. I got pauses or something. Okay, so that was that. Oh, there's more. Find K. Oh, let me not erase it. So let me go back. Can I? So I did find K. K equals 4/3. I would leave it as 4/3 because 1/3 is 1.33. I wouldn't want you to deal with repeating decimals. So K equals 4/3. And is there anything else? I think there's something else. And then does it say what's the unit rate? So the unit rate is 4/3 of what do you call inches, or 1 1/3 inches in 1 day. That's how much it rains. And what point represents the unit rate? So what point represents the unit rate? Well, the point that represents the unit rate is this one. And if you can see it, I mean, before I made a mess there, that it's definitely 1 day, right? So the unit rate is over 1 day. So let me write better. 1 day, and inches on top. But you can tell that 1 is okay, right? The 1's okay, but here it's a little bit, that point right there is a little bit more than 1, which is exactly what we found. 1 1/3 or 4/3, whichever one you want to write. So it's 1 1/3 inches per 1 day, which is exactly what we found. Okay, so you just got to be careful on some of the questions on the test, but it's, pretty straightforward. Okay, that's it.